One project which we have at the moment, which is producing major advantage, is funded by the Technology Strategy Board, which is a UK funding body funded by the Westminster government. It's called ACCUFLEX. It's also jointly funded by industry. The aim is to improve the accuracy of flexo. Now, as part of this, we've come up with a whole new concept of image carrier. We kicked around the ideas. When you put a plate onto a conventional cylinder, you've exposed it flat, and then you're going to distort it as you put it on the plate and attach it with double-sided tape. We first looked at the concept of what if we put it onto a sleeve? What if we coated the sleeve and then engraved it in the round? Would that produce an improvement? Then we realised that if we were going to do that, to ensure that we had the run-out, that is the difference between the rotation of the plate cylinder and the rotation of the surface that's being printed, then we would have to do all this while the carrier sleeve was sat on the mandrel. So in which case, and also if you took the carrier off and put it back on, unless you put it on in exactly the right position, you immediately lost all your run-out accuracy. So this meant there was no real advantage of using carrier sleeves. So what we looked at was actually this new concept. And this new concept is based on directly coating the plate cylinder. The plate cylinder is directly coated in a polymer material which is compatible with the ink that we're about to print. It is then ground on its bearings to make sure that its top surface is perfectly concentric compared to the axis of rotation of the plate cylinder, and the surface is then laser engraved, which enables us to control the profile across the top of the dots, as well as the image itself. We ran this as a first trial in April 2010, and we could run this accurately printed across a 500mm wide web with only 1 thou engagement. The advantage of that is that if it's only 1 thou engagement, then the distortion difference is minimal from one side to the other. The other thing which we've worked on with ACCUFLEX is registration. We are fortunate that we have nearby us a company specialising in online web inspection and control. We've been working with them to develop closed-loop control which is appropriate for the electronics industry. We are essentially looking at getting a registration which is better than 10 microns. The registration mark was developed specifically for printed electronics. It's shown with coloured blocks here, but you have the base. The first pattern down is the black, and the second and third pattern down, the cyan, magenta and yellow, are square blocks which can be lined up accurately using a web inspection camera with the sharp edges of the boxes beneath. And this is enabling us to get better than 5 micron accuracy. The disadvantage is these are really high resolution web inspection cameras. They are approximately 4 times the cost of a graphics web inspection camera, and if you're printing electronics you want to put one on every unit, so your cost of web inspection and registration control for high quality printed electronics goes up by a factor of 16. So what do we actually need to print polymer electronics? Conceptually it's the same as printing quality graphics. The underpinning science is exactly the same. You need a precise press. You need to make sure that the maintenance is done on it, in that it operates, there's no gear marking, and it operates with a lack of vibration. It needs to be stable, and you need to operate with a low nip contact. You need to operate with standard operating procedures to reduce waste. This is because mistakes cost much more, and therefore it's much more important to get it right first time. The other issue is the need to minimize chamber volumes. Now this is an area that we're working on with some of the supplier companies. One of the issues when we look to print some PV on our 4-unit flexo press was it was going to cost us nearly 15 to 20,000 euros just to fill the chambers on our press. So why do we need to get it right first time? The inks are expensive. Conductive carbon inks are maybe twice the price of conventional carbon black graphics ink. Silver ink is relatively cheap as well, perhaps 750 euros per kilo. When you start to get onto PDOT and then onto the more exotic inks like the carbon nanotubes and the graphenes, then the costs start to ramp up dramatically. It was said a few years ago that when graphene wasn't in volume production, the cost of a coffee cup full of graphene of research grade would be approximately the same as the GDP of America. So some of these materials are very expensive. Although we're working now with carbon nanotubes that are being conditioned and dispersed, which are now starting to move down to commodity prices. And these carbon nanotubes are capable of making semiconductors. When you get into biosensors, enzymes and antibodies, you still need to be quite careful, and these baseline materials can be very expensive. And I've already mentioned the cost of PV. What do we need in terms of substrates? We need high quality surfaces. Generally, good quality substrates are good for some applications, and if you were printing it directly onto packaging, attention to detail and a good quality paper or foil substrate would probably be sufficient. But if you get into the printing of wide area lighting, then you start to get into engineered substrates where the surface has been preconditioned and rolled to achieve different effects. You also need to have these coated substrates. A lot of the materials that are used in printed polymer electronics are sensitive to the environment, so you need barriers to actually separate them from the environment to ensure that they have a reasonable working life. And the other problem with the right first time, when you print a full colour graphics job, that's 4 layers. If you print an electronics job, such as printing wide area lighting, you could be printing 10 or 12 layers down to get a product. And each time you print something down, you are adding significantly to the value of the material, of the work in progress. So, what can we conclude from this? Printed polymer electronics is a major disruptive technology. It's a new ways of making new products. Graphic printers can add value to products by integrating electronics. Manufacturing process cannot be then treated as a craft. You do need to understand the underpinning science so that you can consistently produce an electronics quality product. There are other complex electronics products that will not necessarily be made by existing printing companies. Examples of these are wide area lightings, e-books, etc. It's quite likely that new companies will be set up, or if existing printing companies moved into it, it won't be a new job for their existing lines, but it will be setting up a new production line to higher manufacturing tolerances. So I'd like to thank you very much for your attention. I'm sorry I couldn't be with you today. If you have any further queries, then you can contact me at the address shown on the slide. Thank you very much.